Okay, so picking up where we left off on page 65, you may remember this from when we did this with quadratics. It says write the simplest polynomial function with the given zeros. So this is just like what we did last time, where you start with the answer and then you end up with your equation. Okay, so we're going to work it the same way. We're going to start with our answers. So x equals -2, x equals 3, and x equals 8. I'm going to set each one equal to 0. So I'm going to add 2 to get x plus 2 equals 0. Subtract 3 to get x minus 3 equals 0. Subtract 8 to get x minus 8 equals 0. So these are all my factors, x plus 2, x minus 3, and x minus 8. So I'm going to write my equation, y equals x plus 2 times my next factor, x minus 3, times the next one of x minus 8. Okay, once you've got it written like that, it's really easy to put it in standard form because all you do is multiply it out. We've been multiplying polynomials. We did that the other day, right? You did it on your quiz, whatever was the last day I saw you, Tuesday. All right, so we're going to multiply, and just like always, we're going to multiply the first two and kind of ignore the last. So I'm going to do x times x is x squared minus 3x plus 2x minus 6. If you want to, you can go ahead and distribute there, but it's easier if you combine like terms and then distribute. So x squared minus x minus 6 times x minus 8. Welcome. And then distribute again. We're on page 65 in the notebook. You get x cubed minus 8x squared minus x squared plus 8x minus 6x plus 48. You're going to end up with y equals x cubed minus 9x squared plus 2x plus 48. Do you remember doing something similar to that with quadratics? Fairly? Okay, so I'm going to get you started on part B, and then I'm going to let you finish it. So I'm going to let x equal each one of these. What's my first step when x equals 1/2? What am I going to do first? Multiply by 2. So that's going to give me 2x equals 1. If I'm trying to set it equal to 0, then I would subtract 1 to get 2x minus 1 equals 0. And the next one, we're going to multiply by 4. Get 4x equals -3. Set it equal to 0. You're going to add 3 to get 4x plus 3 equals 0. And you get x minus 1 equals 0, and x equals 0.
Teachers, please pardon the interruption. At this time, if you would send advisory groups Nitz and Wyatt to take their pictures. Thank you.
So for this one, you're going to have 2x minus 1 times 4x plus 3 times x minus 1 times x. Go ahead and multiply those out. All right. Woo. There you go. There's no shame in making mistakes because clearly I made my own. Do you want to tell me how this one go for you? Is it okay? It's better than none of it, right? I'll take it. All right. Now we're going to go back to page 66. Page 66, I think.
Why are we coming back?
Huh?
Why are we coming back?
Because we didn't finish the notes the other day.
Oh, yeah. Was the homework going to be like way harder?
No.
2 more questions.
Yeah.
2 more?
Yes. There was only going to be 10, yes. But then I had to totally change it. So I just gave you 8 problems that were familiar. And then I have to wait and see how far we get today before I make the new homework. So, good times.
Are we snowballing?
No. We're still way ahead of the every other day Algebra 2 classes. So. No, I mean Mr. Stambaugh's classes. He just moves slower than I do. That's okay. All right. So on this one, we had to do synthetic division twice, right? Because we started with an x to the 4th, and we don't really know how to factor or solve quadratics until we get to a quadratic function. So how many solutions am I going to have this time? 5 solutions. Okay. So how many times do I have to divide this to get to an x squared? If I'm starting with x to the 5th, I have to divide it. How many times to get to an x squared? 3 times. So I'm going to do synthetic division 3 times. What? Yep. I'm starting with an x to the 5th. I need to do synthetic division until I get it to an x squared.
Why do we need to do x squared?
Because you know how to solve quadratics. In theory, you know how to solve quadratics. Because we solve quadratics all those different ways, right?
Sure.
So we want to get it to a quadratic because then that's familiar and you can use quadratic formula or square roots or completing the square or whatever to solve it from there. Okay, so that's what we're going to do. We're going to do synthetic division. So let's set it up. My coefficients, 1, -4, 5, -10, 4, and 24.
Pardon the interruption. We need students from advisory group Hubbard and Urban to go down to the auditorium for pictures. Thank you.
Okay, just like last time, we're going to use our calculators to find our zeros or the numbers that can go in the box. So we're going to type in very carefully because I think I've typed these in wrong every time. x to the fourth plus 5x cubed minus 10x squared plus 4x plus 24. Okay. Welcome back. Okay, once we get it typed in, where do I look to find the numbers that go in the box?
Second graph.
Yep, second graph. Want to look at the table.
Oh, I got it wrong. I mean, now I got it right.
Did I type it in right? Yes, I did. Okay, so how many times did I say we're going to do synthetic division?
3 times.
3 times. Do I have 3 numbers here?
Yeah.
-1, +2, and +3. It does not matter which one you start with. Pick your favorite and go with that. You're going to have to do synthetic division 3 times. The order does not matter. Mary wants to start with -1, so we're going to start with -1. 1 times -1 is -1. This is -5. +5 adds to give us 10. 10 times -1 is -10. Add to get -20. Multiplies to give you +20. +24 times -1 is -24. You get a remainder of 0. What does it mean if I don't get a remainder of 0? I did it wrong. Okay, if I know I'm just going to do synthetic division again, let's all save our pencil lead and not rewrite it. Let's just make another box right here. Oh, I'm so sorry. Would you rather do long division?
Oh, yeah. No, I use it even more long. Such short math.
Okay, what's another number I can put in the box? I don't have to retype it.
2 and 3.
Yep, 2 and 3. So I'm going to start with 2. Okay, then we're going to do synthetic division one more time. One times 3 is 3, you get 0. 0 times anything is 0, add to get 4. 4 times 3 is 12, add and you get 0. Okay, so I took an x to the 5th, I divided it and got an x to the 4th, divided it again to get x cubed, divided it again, and now I have an x squared, right? So this is really x squared plus 4 equals 0. How do I solve that?
I don't know.
I hope you know. Yep, I'm going to subtract the 4 and then square root. So subtract 4 over, you get x squared equals -4. Then you take the square root of a negative number. What happens when you do that? Plus or minus 2i. Okay, so you told me we were going to have 5 answers, right? Because it's an x to the 5th. What are my 5 answers? Yep, all these numbers from the boxes. So x equals -1, x equals 2, x equals 3, positive 2i, and negative 2i. They're all 5 answers. Wait for it.
Okay, teachers, please pardon the interruption. We need students from advisory group Hallie and me, Hannah, to go down to the auditorium for their pictures. Thank you.
All right, so just like last time, we're going to write our polynomials. And then just like what we did with quadratics, if I have a positive 2i as one of my answers, what other kind of answer am I going to have? Do you remember? A negative 2i. Okay, I don't know why they try to confuse you by only giving you one of the imaginary answers, but they do. Right?
Plus or minus not valid.
What?
Plus or minus not valid.
Yes, you could put a plus or minus right here if you wanted to. Okay, then we're going to write our polynomial just like we did whenever we didn't have an I. So we're going to set x equal to each one of our solutions. And then set each one equal to 0. Okay, when there's an I involved, I always recommend multiplying the I's together. The ones with I, multiply those together, because then your I will go away. So I'm going to multiply the first two together, then the last two together, and then I'll multiply all of them together. X squared minus x plus 2x minus 2. And x squared plus 2ix minus 2ix minus 4i squared. So we get x squared plus x minus 2. My two middle terms here will cancel out. That will always happen. Bless you. So then you have an x squared. What do we know about I squared? It's negative 1. So this is negative 4 times negative 1. So this is really x squared plus 4. And then distribute again. X squared times x squared is x to the 4 plus 4x squared plus x cubed plus 4x minus 2x squared minus 8. Then combine your like terms and put it in standard form. So x to the 4th plus x cubed plus 2x squared plus 4x minus 8. Whew. Okay, do you want to do that next example, or do you feel like you know how to do it and you would rather do it later? Later? Okay. I feel like it's multiplying out. Did you already do it? It's the same thing? Do you want to know the answer? Should be x cubed plus x. Okay. So if you do that one, you'll get y equals x cubed plus x. But But if you already feel comfortable with it, I'm not gonna make you multiply it all out again, because that was a whole lot. Nope. No. Oh, okay, now we're on page 67. It says irrational roots.
I thought it said fraction.
You're gonna wish it was fractions. Traveled far. All right, so we're gonna solve this one just like we've been solving, because it's not gonna factor. So we're gonna set up synthetic division. 2, -3, -10, -5. How many solutions am I gonna have? 3 solutions, because it's an x cubed.
Teachers, please pardon the interruption. At this time, if you could send Garner and Nichols advisory group to the theatrical pictures. Thank you.
So type it into y equals, and then use the table. Figure out what number goes in the box.
What was those numbers happening in reading?
Huh?
What was those numbers happening in?
I don't know. Type it in and find out.
He wants to make sure his numbers.
Oh yeah. Well, tell me what you got, and I'll tell you if you're right.
-1.
Yep.
I'm just guessing.
Mm-hmm.
Guessing.
Yeah. Good job, Jonathan via Micah. What?
I didn't say that.
No?
He did.
Oh.
Okay.
Mm-hmm. All right, so 2 times -1 is -2. -5. -5 times -1 is +5. Add to get -5. -5 times -1 is +5. You get a remainder of 0. Do I need to do synthetic division again? Nope, because now it's an x squared. So I have 2x squared minus 5x minus 5 equals 0. Weird. Okay, what's your instinct on how to solve this? AC method or guess and check.
No.
Okay, 2 times -5 is what? -10. What are factors of -10 that add to give you -5? Factors of -10 that add to give you -5? We're on page 67.
There are none.
There aren't any. This one does not factor.
Oh, no. Oh, wait.
Oh, wait. What do we do?
We give up.
Nope. Guess and check's not going to work either.
We voted on one more time.
What? Synthetic division? We can't do synthetic division again because there were no other zeros on our table.
We can look some more.
Huh? You can look some more? Keep looking. There's not any more on there. We're going to do quadratic formula. What is the quadratic formula? I'd probably write it down because some of you wrote it down wrong on your test. Make sure when you do the all over, it's literally everything, including the negative b, all over 2a. What? All right, so you're going to plug in a equals 2, b equals -5, and c equals -5. Your quadratic formula. Except now you have a calculator, which you didn't have before, so use that to your advantage.
Teachers, part of the interruption. We need students from advisory groups, Parsons, and Tufts to go to the auditorium to take their pictures. Thank you.
Second mode. That takes you off the graph. It takes you back to your home screen if you do second mode. Mode. Button right there next to it. Okay, does the square root of 65 simplify at all? Breaks down into 5 and 13. Either one of those are perfect squares. So it does not simplify. So how many answers do I have right here? 2. How many do I need? 3. What's the other one? -1 from the box. Okay, go ahead and try part B. So great, your favorite problem you've ever done.
Oh, yeah. These kids are too many lines.
All right, we're only going to do one of these. No, we're going to at least start the graphing notes. This is part of algebra. Helps you make the connections between all of the algebraic things with all of the graphs. Yes. No, not necessarily.
No.
Okay, so just like last time, if they give you a negative square root, just like with the i's, if they give you a negative square root, you are also going to include the positive square root.
has 3 terms?
Yep.
Wow.
So you're going to end up with an x cubed. Set each one of those equations equal to 0. And you're going to multiply all of those factors together. Okay, anytime you start with an answer that has an I or a square root, your final equation will not have that. These terms are going to cancel every time. What's the square root of 9? So this is x squared minus 3 times x minus 5. You get x cubed minus 5x squared minus 3x plus 15.
That was easy.
That was easier? Good. Okay, now all you have left in your sleeve or your sheet protector are a bunch of books. You need the one that says 3.7 graphs of polynomial functions.
Wait a minute, what is this?
And it's going to go on page 68. Okay, so you're going to do this either on your own or working with your neighbors. What? No, you're not going to wait for me to do it. Okay? Because we're going to read the directions. It says use a calculator to graph each function. Draw a rough sketch of each equation on the graph below. So it's not going to be beautiful, wonderful, amazing graphs. You're just drawing a rough sketch as to what it looks like based on what it looks like when you graph it in your calculator. Okay, so take some time. You're going to graph 6 things in your calculator. So go to y equals, type them in, then hit graph, and then sketch a rough graph of what that looks like.
Wait, I didn't even get that one back. Oh.
Why didn't you get that one back? All right, do yours look kind of like mine? Rough sketch. Close enough. Okay, do yours look like your neighbor's? Check your neighbor. Check your neighbor's graphs.
Do they match those?
Okay, do you notice any patterns? They're weird. Are there any patterns to the weirdness?
It starts over.
It starts over.
Like, it goes to the normal one, then the weird, up and down one, and the W, and then another W one, and then the U, and then the.
Did you say that's a W?
Yeah.
Kinda. It's got an extra little thing here. Okay.
An aggressive W.
Okay, any other patterns? Specifically left versus right?
It spells.
They are not letters, people. What? What patterns? All even numbers? Okay.
All the ones on the left go to 0.5.
Yes.
And then on the right, they go up and down.
Exactly. Okay. All of these had even numbered degrees, right? Second degree, fourth degree, sixth degree. And all of these opened up, both of them. So when it was an even degree,
I can't see that.
I know. Both arrows point up. What do you notice about all the degrees on the right side? Yep, they're all odd degrees, 3, 5, and 7. And when that happens, you have an arrow pointing down and an arrow pointing up, right? They go in opposite directions. Okay, so
I know, I see.
yours is 25. So what would you expect a 25th degree polynomial to look like?
Number 5.
Teachers, pardon the interruption. I need students from the following advisory groups, Craig and Jay Wright, to go to the auditorium for their pictures.
Okay, so
Craig and Jay Wright. Thank you.
25 even or odd? It's an odd number, so is it going to go in the same direction or opposite directions? Okay. So it would look something like this. Arrows will point in opposite directions. What? Okay, now we're going to go back up to these graphs right here. And I want you to regraph 1, 3, and 5, but I want you to make each of these leading terms negative. So do negative x squared, negative x to the 4th, and negative 3x to the 6th. So you're going to type them in again, you're going to graph them again, but this time make all of those negative. Okay, but they all open down, right, when it's a negative in front? Did any of you graph these negatives? Okay, what it will do, a negative in front like that, all it's going to do is flip your graph over. So this one should look something like this. Okay, this one is going to flip over. So my arrows, instead of starting down and going up, it's going to flip and start up and go down. Okay, that is all based on what the number in front is, if it's positive or if it's negative, which is exactly what they talk about right here. Okay, so knowing what the graphs of polynomial functions look like can help you describe the end behavior or the arrows of your functions. So polynomial end behavior, leading coefficient, that just means the number in the very front. So when the number in the very front is greater than 0 or it's positive, if it's an even degree, both of your arrows are going to point up. If it's an odd degree, it's going to end pointing in the positive direction. If your leading coefficient, or the number in the very front, is negative, if it's an even degree, they're both going to point in the negative direction. If it's an odd degree, it's going to end up pointing in the negative direction. So to the right, it will point to the negative. Okay, end behavior in theory is not hard. Like, you can pretty much picture what the arrows are going to do. The hardest part about end behavior is the notation, because they write it really weird. Okay, so f of x really means your y values. So this is saying that your y values are going to approach. So this is y values approach either negative infinity or positive infinity. So either in the negative direction or the positive direction. Y values are up and down. As your x values approach positive infinity or negative infinity, aka left or right. So remember when we did domain and range and we had all those infinities? They're back. Yay!
Teachers, please pardon the interruption. We need the following advisory groups to go to the theater at this time for pictures. Conroy and Dennison. please go to the theater at this time for pictures. Also, just a reminder, students, if you do not have your picture taken, your picture will not be in the yearbook. Thank you.
No one will ever know what the bottom half of your face looks like. Like, I'm gonna look through and it's gonna be hard to recognize some people because some people I only know from here.
No.
You don't have to wear the mask in the picture, no.
But I guess you could if you want to.
I don't know.
They can't make you take it on.
Anyway, okay, example 1, identify the leading coefficient, the degree, and the end behavior for each function. All right, so part A, we have q of x equals negative x to the 4th plus 6x cubed minus x plus 9. Okay, leading coefficient, that's the number in the very, very front. So what is the number in the very, very front of my equation? Negative 1. Okay, then I need to figure out the degree. So what's my biggest exponent? All right, so using my chart up here, if it's a negative leading coefficient and an even degree, leading coefficient is negative, even degree, it's going to go down, right? It's going to open down. Both of them are going to be negative. So no matter if we're going to the left or to the right, both y values are going to go towards negative infinity, right? So to the right-hand side, we're going to negative infinity. To the left-hand side, we're going to negative infinity because both of them were pointing down. Okay, we knew that from degree 4, leading coefficient was negative, so we looked at our chart. Negative leading coefficient, even degree, that's this box. So they're both going to open down. Well, down here at the bottom, my y values are negative infinity. So to the right and to the left, we're going to go to negative infinity. All right, part B. What's my leading coefficient? Somebody said it? 2, which is a positive number, right? What's the degree? So I have an odd degree with a positive leading coefficient. Which box am I in up here? The first one, top left. So on the right-hand side, we're going to positive infinity. On the left-hand side, we're going to negative infinity. Welcome back. So on the right-hand side, we're going to positive infinity. On the left-hand side, we are going to negative infinity. Did you answer your own question? Because I didn't hear it.
So it goes from right to left.
Yeah, well, yes, on these notes. Okay, so try those next two. Use your chart at the top to help you. Okay, check yours with mine. Feeling okay about this?
Not really, I didn't see what's the point.
We'll get there. Well, we're gonna graph these here in a second. Yep. All right. So on the next page, it says identify whether the function graphed has an odd or even degree and a positive or negative leading coefficient. So using that table on the left, we're going to figure out if it's positive or negative degree. Nope, positive or negative leading coefficient, or even or odd degree.
Oh my god,
What?
I don't want to.
You don't want to?
Wait. No, I don't want to.
All right. So on the first one, part A, are my arrows going in the same direction or opposite directions?
Opposite.
If they're opposite directions, is it even or odd? So it is an odd degree. Okay, well, my leading coefficient, I need to decide if it's positive or negative. So really, to do that, I only have to look at the right side. Whichever direction that arrow on the right is pointing, that tells you if it's going to be positive or negative. So am I pointing in the positive or in the negative direction? So my leading coefficient is negative. Okay, part B, even degree or odd degree? Why even?
Because it does go up.
They're going in the same direction, so it's an even degree. My leading
Pardon
coefficient,
the interruption.
positive or negative?
I need students from the following advisory groups to go to the auditorium for their pictures. Jay, Johnson, and Jones. Jay, Johnson, and Jones. Thank you.
Thank you. Okay, what about the last one? Yep,
Even.
it's the same thing, even degree. And a positive leading coefficient. Okay, so now you know all the basics. You know factoring, solving polynomials, and behavior. You can graph a polynomial function. You know all the things to do this. Okay? So we're going to graph this function down here at the bottom, and literally it tells us step by step what to do. So this table right here tells you exactly what you need on your graph. Okay, so find the real zeros and the y-intercept of your function. Okay, we're going to use the calculator for this. So if I'm trying to find the zeros, let me write it over here. The zeros are where which, x or y equals 0? It's where your y equals 0 because they're on the x-axis. Okay, and your y-intercept is where x equals 0. So if it's an x cubed, am I going to have 3 zeros? Yes. Okay, so go to y equals and type this in. And then use your table. There should be 3 different x values that have a y value of 0. You have like the 5 of you that are typing this in. Tell me what you get for your zeros. +1, -2, and -3. So at +1 on your x-axis, -2 on your x-axis, and -3 on your x-axis, you have 3 points. Okay, the y-intercept happens when y equals 0. Nope, that was a lie. When x equals 0. 0, -6. You don't even need your table for that, but you already have it, so you might as well use it. X. Okay, step 2 says plot the x and y intercepts. I just did that. Step 3, make a table for several x values that lie between your real zeros. All right. So I have -3, -2, 0, and 1. So I'm going to figure out in my table the values around that. So I'm going to do -4, -1, and +2. But remember, you've already typed this into your y equals. You've already got the table pulled up, so you're literally just filling in these numbers from the table that you have on your calculator. So the table on your calculator tells you you have the point -4, -10, -1, -4, and 2, 20. Obviously, that last one's not going to fit on your graph. Okay, plot the points from your table, -1, -4, and 220 is going to be way up here. And then we're going to do a sketch or draw our graph. And there are some graphs on your homework. Probably there's only 6. Okay, so I'm going to give you the graph paper. If you do not get your graph finished on your homework, that's okay. I'll give you time in class.
Oh, this week does go by.
So we will finish the notes, and I'll give you some time to finish the graphs in class next time. But on your homework, that's going to post here in a few minutes. You need to do the non-graphing questions at home before you get here on Monday.
Procrastination all the way till Monday.